So, okay, let's dig into this topic. So, when I was thinking about how to talk about reactive programming, I sort of reached around for some, analogy, something in my past or something that I, could relate to easily. And I found one thing that was very easy for me as an Englishman to talk about, which is the extremely sophisticated matter of drinking beer in a pub. Yeah. So, drinking beer. It's, depending how you factor it, kind of imperative, right? I mean, this is an imperative implementation, or at least a flowchart of it for drinking beer. Why is it imperative? Because it's got a loop. A loop is, it's an imperative programming construct, right? It's one of the things that we use day in and day out, unless you're like writing functional code all the time, in which case maybe you don't. But this is basically the way that we would sort of look at it. We'd sort of say, while true, because of course we don't want to stop, order and then drink, okay, and so we go. But actually, this is the way we once would have had to write it in, say, C#, back in the days of version 1, version 2, the bad old days. But over time, things have changed. And we got more options. We can express it in a much more functional style here. I like my beer to be very pure, so this is a very pure way to drink beer using functional programming. So what's going on here? Well, the first thing that I've done is grab these things. There's a library called the interactive extensions, which basically give you a bunch of extra things on enumerables. Now, I don't know, so how many of you here read C# easily? Or does anybody not read C# easily here? Nobody? The odd one. Okay, let me tell you what this is doing anyway. So, what this is doing is it's basically getting the menu here, which is an object representing the menu of beers. And what I'm doing is I'm actually making an infinitely long sequence of menus here. Okay, so I'm getting the menu, and then I've got as many as I want. Now, of course, it doesn't compute that because your computer doesn't have infinite memory. What it does is it sort of hands you the menu, just as you need it. Just like when you go to drink at the bar, you can ask for the beer menu as many times as you want. And then what we do is we take the menu and we choose a beer, and that's our chosen one, and then we order it. Okay, and then we take 4 of them. That'll do. That's a fairly light evening for an Englishman, but okay. And then we'll do a dot for each, and we'll just pass this drink method off to for each. And if you kind of look at this, interestingly, we don't actually do any work until that very last statement there. In fact, the way that this works is that all of this in green is what we call lazy. Kind of like me on the morning, okay? So what it does is it just sets up a little pipeline here. So it says, okay, here's a menu, and here's something that can produce lots of menus, and here is something that produces a choice, and here is something that orders it, and here's something that basically keeps pulling values through this pipeline until we've seen 4 of them. And it's not until we actually get down to the very bottom here that we actually need values. For each is something that demands values. It says, I need something to work on. So the thing about all of this is that it's blocking. Okay, so that call there, that order, okay, what happens when you're drinking beer and you have to order one more? You're blocked. Okay, you're sat there waiting, feels like an eternity, eventually it comes. Okay, and then you go around the loop again, and you're blocked here. And blocking is something that it happens all the time in our programming. I'd actually like to just label this as interactive beer drinking, which is often sort of seen as maybe the opposite of reactive, which is what we're here to talk about. And it is actually pretty normal to us, I think. But the thing is that we are so used to it that it gets a bit hard at times to sort of cast the problem in a different way. Really, blocking is part of the whole paradigm of interactive programming, where we make synchronous calls. Okay, so I call a method, and what I expect is that the method will complete and it will produce a result, and it will give me the result back. And there we go. Now, at the pub, beer drinking is typically interactive. And at this point, you might sort of wonder, why did I pick it if it's a bad example of reactive? And the answer is, when I lived in Slovakia, I discovered that reactive beer drinking exists. Okay, so how did this work? I could not believe this when I first saw it. Okay, at the end of the table was a lot of beer. And every so often, beer would be pushed to the table asynchronously. Okay, so a waitress would come, or waiter would come, and just put some more beer on the table. And the drinkers would, observe this drinks buffer, and as soon as they needed another one, they could just take it. Okay, this is very nicely, loosely coupled beer drinking here, but this is reactive. This is, just reacting to the fact that someone has actually put a beer in this place that you're observing. And of course, you can have a whole little buffer of them there. So this is asynchronous and non-blocking beer consumption. And, well, that sounds good. But the thing is, whenever we hear things like asynchronous, one of the common reactions, maybe you feel this, is, oh, that's the hard kind of programming. Who thinks asynchronous is a bit harder than synchronous? Yeah, that's yeah, me too, okay. It's human. If you look at the way that people work, we like to tell stories, we like to talk about what we did in the day, and it's all very synchronous. I did this, then I did that. We don't tend to talk about things happening in parallel. It's not so much in our nature. And we're kind of challenged on that when it comes to asynchronous programming, because things can be happening at the same time in any order, and I think that's why we find it tricky. And of course, even just looking at this simple situation of somebody bringing beer to a table and people asynchronously taking it. Okay, what happens if, as the Slovak waitress is putting the beer there, and I sort of reach out my hand and I meant to take a beer, but now I'm holding hands with her. Okay, I'm British and she's Slovak, so it's a race condition. So, thank you. So, okay. But the other thing is all the callbacks that tend to characterize a lot of asynchronous programming as well. The idea that, well, okay, we'll set this operation off, and when it's done, here's a piece of code to run. So what happens if you want to do something when that has also been done? Well, we could nest another piece of code in there, which makes another callback. And you end up like 20 levels of indentation deep, and it's really horrible. So in general, asynchronous programming has sort of been one of those things that traditionally we maybe have shied away from, because it is different. The tools have often actually not made it so easy to factor things well and elegantly and composably. That is, I can take two things and put them together, and they still work sensibly, and it's easy to do that. So let's take a look at what the reactive paradigm sort of sets out to do, and how it tries to take on this problem, and why it takes it on in a way that we should be able to find reasonably graspable. Now, if you think about interactive programming, or doing anything like this, what we're doing is essentially pulling, okay? So I mentioned to you that whole top bit is lazy. What I mean by that is that down here, when we want to have a drink, we call up to something here, and in any language with some kind of iterator or enumerator or whatever names we like to give to these things, there's always a method like move next. Okay, give me the next thing. So all these are method calls. They're called all the way up the chain. Okay, so give me a value. Well, I can't, but this guy can. No, I can't. Maybe he can. Maybe he can. Okay, finally a value. Okay, and then the results flow back down the pipeline until we do something with it, and then we can pull more of them through. So this is very pull-based. And it's all about enumerables. What's going on with that code that I showed you, that query, that is selecting this and sort of just dragging it through that pipeline there, is it's setting up a chain of enumerables, okay, or chain of enumerators. Things that know how to produce a sequence of values or take a list of values, manipulate them, and give other ones back. Now, the enumerator pattern is something that's been very long known, and we can define lots of what we call combinators on this. Now, a combinator is just one of those fancy words for a thing that only operates on the parameters we give it. Okay? So if you think about select is a projection. It's a thing that takes, what do we have here? Okay, here it takes in the chosen beer, and it actually gives out an ordered beer. Okay? We have where, which filters. So it takes in an enumerable, and each time it has to give a value, it says, okay, does the current one that I just pulled match? If yes, pass it on, we're done. If not, no, ask for another one until one does match. So what we're doing is just wiring together these little pieces that know how to obtain a value from somewhere, maybe manipulate it, maybe transform it, maybe make groups of them, maybe select, sort of filter them and so on, and then pass on results. The reactive paradigm basically arose out of realizing that there's another design pattern, besides the enumerator pattern, that shares a very interesting relationship with enumerators, and it's the observer pattern. Has anyone used observers? Yeah, what have you used observers for? Anyone?
Reacting to change.
Yeah, reacting to change. I mean, the observer pattern, what's the observer pattern? I'll come back to that. It's really great. Okay, let's do this first. The observer pattern is where we're observers, okay, we have an observable object here, and the observers subscribe. They say, I'm interested in knowing stuff about you. And whenever something interesting happens over in this object, it's got its list of observers and it goes and notifies them. Okay, it tells them, oh, something happened, or something happened. Now, why this relates to category theory, there's a concept called mathematical duals. Basically, duals come out of category theory. Now, I'm not a category theorist, but essentially there's one really, really important result that comes out of all of this. All of those combinators, like where and select and let and so forth, that make sense to define on enumerables also have a sensible definition on observables. Okay, so you can actually, and you can sort of see this maybe, let's take where, okay, you could have a value asynchronously being pushed at you, and it arrives, and you're observing the place these values come from, so you're notified something happens. Okay, and what you can do is you can look at it and say, does it match the pattern? Okay, and you yourself can also be observable, so then you tell who's observing you. Oh, here's a value that matched my pattern. Okay, or you just drop ones that don't. So what you end up with is being able to define all of these things on observables just like you can on enumerables. And that's where the reactive paradigm came from. This is really very powerful stuff because, you know, it lets you reuse all of the knowledge you have about working with enumerable sequences, but then use it to build up asynchronous things. By the way, who understands category theory? This is for you. Is it funny? Only if you do Skyrim too, right? Yeah. Okay, fine. One day I'll have a room of people who all find this funny, and then I'll run away. Okay. So, Rx, the reactive extensions. So, well, this actually came out of Microsoft, a guy called Eric Meyer, very, very cool guy. And he was heavily involved in bringing us Link, which is the very nice language-integrated query stuff that I showed you before. But it's actually really sneaky because Link basically is a bit of functional programming, sort of sneaked into C#. And everyone's like, oh, that's great, without realizing they're doing FP. I kind of like it when you design something that lets people use fairly interesting and great concepts without sort of ramming into them, oh, you're doing this cool thing, this concept. No, people just get on and solve their problems. I kind of like languages where they do that approach to language design. But anyway, we got LINQ. We got the ability to write these queries over these sequences. But the thing that they did is they basically made it independent of the sort of data you had. So if you wrote a LINQ query and your data source was a database, there was enough information around at runtime to translate that into SQL and send it off to the database. And there was enough flexibility in that, for example, queries over objects, they could just take and then drop in a new implementation called parallel LINQ, and suddenly your queries are being parallelized across your different CPU cores. So this was very elegant design. Now what they realized with RX is that the same sort of infrastructure can be used to set up chains of observers. So it actually implements a lot of the same combinators, select, where, and so forth that you're used to, maybe, from doing things with, say, LINQ or most other languages that provide any kind of functional programming support at all. Maybe they call them map and filter or map and grep. Okay, there's lots of names to these. But, they all have them. And the beauty of RX was realizing, oh, well, we can do these on observables too. So I'm going to show you some examples in C# today, and just to show you how you can go and play with this right away if you want to, you just go and install RX from NuGet, okay, and then let's write our first little bit of RX here. So we'll just finish up the beer example first. It's kind of silly, but it makes sense to finish on this path now that we've started, and then we'll do some really cool other stuff as well. Okay, so let's get just a random number generator here. Okay, and what we're going to do is we're going to take the class observable. Now, observable has a bunch of methods on it that manipulate, well, observables or produce observables. Remember, an observable is something that we can choose to observe. And this first thing here, this .interval method, okay, here we make a time span of 2 seconds. What this does is it creates an observable, and if we start observing it, what will happen is every 2 seconds it will just send us an integer. Okay, it'll send us a 0, 2 seconds, 1, 2. Okay, you get the picture. So what's going on here is that every 2 seconds we're notifying anyone who's interested. So who's interested? Well, it turns out that this select is. Okay, because being just chained as a bunch of method calls means I'm interested in observing the last thing. So it sets up all of this observing for you. So this select here, every 2 seconds, will get a number which it completely ignores. Okay, because we're not really interested in the number, we're just interested in the timing here. And what we'll do is we'll choose a beer. Okay, so here is the menu. And I'll just pick a random one. Okay, that just gives me a number between 0 and one less than the count there. So we'll pick a drink. Okay, and but of course we're not really picking here because well, we sort of are. But this is the waiter's view of it. Okay, every so often, more than 2 seconds, but every so often the waiter is going and saying, oh, I'll pick this one. And what they do is they go off to the table and they're going to serve a round of this. Now, do is something that essentially lets us just serve a little side effect in there. It's something that lets us just say, at this point in the pipeline, I'd like to just run a piece of code. And sometimes this is kind of useful because what you'd like to do is actually take what you've got so far and maybe just write it out either for debugging or maybe you want to log something or something like that. So all I'm doing there is I'm just saying serve the round of that drink. Okay. Now, we've been instructed that we should only serve this table 4 rounds of drinks. Okay, so that's probably wise. And then what we're going to do is we're going to actually make this into something that many people can observe. Now, one of the things I hand-waved about that is kind of important to understand is the point that this whole pipeline of observables actually starts coming into play. Now, the thing is this. When I set up this pipeline down to take 4, I've actually only described it. Okay, this is what we call declarative, or just declaration. I haven't actually started producing the 2-second timings yet. Okay, I haven't done any of the work that follows on from it down to here. What I've done is I've just set something up so if somebody comes along and subscribes, okay, there's a .subscribe method, at that point, what will happen is we will go all the way up the chain until something is at the start of it, we'll subscribe, we'll start observing all the way up, okay, and eventually from here we'll flow down the 2-second pulses. The thing is that we're actually going to have multiple people observing this. So what I'm going to do instead is I'm going to call publish, which, is anyone familiar with publish subscribe? Okay, the idea where maybe you've done this in your applications, you want to tell different places that something happened. So what you do is you sort of have events and you publish them, and have a bit of your application listen to them and their subscribers. Okay, and what we're going to do is we're actually just going to do a bit of publish subscribe with this. So what we're going to say is at this point, if anyone actually comes and starts observing this table, I don't want you to go all the way up this pipeline and start another round of drinks. Okay, I want to share this between the whole table. And the table connect method is there just to say, okay, we're ready to start now. That actually makes this go and do the subscription up here. Okay, so here are some drinkers, okay, slightly fabricated. You can see I'm kind of fast, and my boss is slowest. Don't tell him, he's not here, it's fine. Oh, there's a video, oh well. Okay, so here is what we do. We have this IObservable. So this might remind you of IEnumerable, okay? The interface describing an enumerable, something you can pull. And just like IEnumerable is type parameterized, so, you know, is it a bunch of strings we're getting? Is it a bunch of cats or whatever? IObservable also is, and this sort of tells you what sort of values are being pushed, okay, for this pipeline. And what I can then do is I can take that table, I can say I want to actually observe it over on the task pool, okay, so we don't block. You'll notice that I'm doing this over here in a thread. Okay, and what I'm going to do is I'm just going to do another side effect there, and I'm just going to wait until we've seen all of the things. You might remember there's a take 4, which means only 4 things are going to go through, okay, and we'll wait until they're done. So what will happen with this is that all of the drinkers, okay, will be looking at the table, and they'll be attached to the same flow of rounds of drinks, and they can all take one and then consume it at their own pace. And of course, if I run this, let's try this. Okay, was that the one? That was not the one. And that's the one. Okay, and if I run this code, then we should start seeing rounds of drinks. Okay, and you can see that they're coming out at different paces because people are going at different speeds. Okay. Cheers. So, there we go. Okay, so you can see that there actually is just a little bit of, again, just sneaking in a do something. You might do it quite a lot when you're debugging. You probably will do this less in real life, okay, just as an upfront warning. So we might not see do quite so much again for the rest of the day. And the reason is that you often don't quite want to do it that way. Okay, it's good for demos, and this one also. Okay, because what you're doing here is a little bit funny. What we've done is we've actually taken this sort of thing that is throwing values at us asynchronously, and then said, oh, synchronously wait for it. Okay, so there's a bunch of places that you can, if you want, sort of go between synchronous, asynchronous. Very often once you're asynchronous, you want to stay there, and the more real sort of examples that we'll look at today will be doing that. Okay, so it's easy enough to make a little example using reactive beer drinking, but how is this useful in real life. I think the world has got increasingly asynchronous around us as developers, and it is kind of everywhere. Ever since web services have come along, you know, when you go and you make this call off to this web service, you don't know when that answer is going to come back, and the service you're calling most certainly doesn't know when the calls are going to arrive. Okay? As part of building any web application, there's a lot of sort of inherent concurrency in there. Things can be happening at whatever different times they like. User interfaces, okay, that's less new. The user can click the button whenever they like. They can type in the text boxes whenever they like. And where things get interesting is when we take various of these, there's domain events as well, and WebSockets, okay, we'll talk about some of these a bit more later. But the thing about all of this is that it gets especially fun, as in hard, when you have to start doing multiple of these together. So for example, I have a user interface with a search text box in it, and the user types something. And I go off and I start making a request over a web service. Then the user changes what they typed in the text box to correct a spelling mistake. At that point, we go off and make another call to the web service. Now it turns out that second call, by some fluke, comes back faster. And we show the user the results. And then, straggling on behind this call from this other web service, the first call that we made with the input the user has now deleted and replaced comes back as well. What do we do? Well, obviously the answer is we should ignore it, because we're already showing the correct information. But that's actually kind of tricky. That sort of problem is not that easy to solve. It's very easy to not think of it, and to end up getting it wrong. And I know, because I've seen plenty of code bases, and especially JavaScript, where this is very common to go off and call services, sort of make those kinds of mistakes. So it's not just an asynchrony is all around us, it's not, we're often expected to compose, and put together, different kinds of asynchronous thing. Be they user interfaces, or service calls, things arriving over WebSockets, and maybe domain events, that is, events from within our application that carry some kind of significant meaning in our domain. Some of this, you know, you can clearly see is related to systems being more distributed. Synchronous programming and distributed systems are not a very good fit. You know, you may have seen systems where, you know, you make a web service call, but in order to answer that service call, it has to make a service call too. Okay, and you end up with all of these calls, and all these machines sat processing that request are holding open, you know, TCP connections. They're holding open maybe database connections. In the worst case, maybe they're in the database transactions that are holding onto locks. And it gets very hard to scale those sorts of things. It becomes very painful very quickly. And, you know, this is not that robust either. Because what will happen is, you know, you get, you know, this design that you look at on paper, and you say, okay, it's a nice design, because this service only is coupled to one other, and this service is only coupled to one other, and this service is only coupled to one other. And on paper, it looks just great. And then you realize that at runtime, there's runtime coupling between all of these. So when you call the first one, you're actually coupled to all of them. Okay, you depend on all of them being up and alive. So just generally, this whole approach of blocking calls, synchronous calls, and, you know, distributed systems is a less than great fit, which is another reason that, you know, solutions in this space have become very interesting. This is why people turn to things like, say, N-Service Bus, for example, which basically just embrace asynchrony from day one, and just say, yeah, things will fail. So, if we're going to have to cope with it, why is reactive an interesting way to do it? Well, to me, you know, the reason that I really like things like LINQ, or any kind of functionally things, is because that paradigm can factor out flow control. Okay, when I used to write things in C# where I wanted to take a list and get things out of it that matched a certain condition, okay, I'd write a loop. Now I don't have to. I can just say where, pass in a lambda expression saying what I'm looking for. Of course, the looping is happening somewhere, but it's hidden to me. It's factored out. And of course, a loop is not that much to factor out, but some of the more interesting things like joining and grouping and sorting, of course, are. Now, what's powerful about reactive is that it abstracts away the setting up of these observable chains and so on, but it also deals with asynchrony. So there's various of the combinators in Rx where, is everyone familiar with the zip combinator in enumerables? Can anyone tell what zip does? What happens if you zip two lists? Okay, if you zip, okay, what you get is two lists. Okay, let's put aside reactive and just do enumerable for a moment. You have two lists, okay, and or two enumerables. And what you do is you take them, and you get a value from each one, and you run a piece of code which takes the two values and returns one value. Okay, and it can combine them together. That's a zip. Okay, it just zips two sequences into one. Now, of course, doing that for enumerables is kind of easy, because you just pull a value from one, pull a value from the other, call the function, and pass them along. Zip, when you're doing asynchronous reactive programming, is much trickier, because what will happen is, as a value arrives, okay, here, another one might arrive here, before a value is pushed towards the second one. So it has to have some sort of window there of, a buffer of incoming values. It has to deal with the fact that both might arrive at the same time, so it has to do the underlying stuff to make sure it's thread safe, because they could come from different threads. Okay, so Rx is not just factoring out the observer pattern. Because of the asynchronous nature of things, it's factoring out doing all of that messy stuff with locks or lock-free stuff or all of that you currently don't want to have to deal with. Now, along with this, you may have come across something called the Reactive Manifesto. And this talks about reactive applications. And the idea of this was just taking this idea of reactive programming and saying, what if we apply it to the whole system? Basically build systems that react to events, load, failure, and users, okay? And you can actually think back to the thing I talked about a couple of minutes ago, about what happens if the user types in something, changes it, and we give them the wrong results. Okay, no, that isn't what users want. They want applications that react to their calls and do the right thing. Here's just a couple of quotes from the Reactive Manifesto. I won't read it, but you can see it, and it's kind of describing the sorts of changes in the kinds of systems that people are having to build now. Here's another one. Okay. Talking about an architecture that is very asynchronous in nature. Okay. So, how do you get to that place? Well, reacting to events means that we need to have events in the first place. And then a little bit later this evening, I'll talk about domain events and how we can get there. But basically, the path all of this leads to is really asynchrony and having to cope with asynchronous things. So let's take a look at two scenarios where it could be interesting to apply Rx. Now, the first one I'm going to talk about is a very naturally asynchronous or concurrent thing. What we're going to do is we're going to go off to Twitter, and we're going to look at the live stream. Okay, now this is a thing where Twitter throws at you every single tweet about a certain topic. Okay, there's quite a lot of them. And what we'll do is sentiment analysis. Okay, we'll try and determine if each of them is a positive or a negative. Okay, and we'll express this using Rx. And then later on, after that, we'll sort of step aside from it, and we'll do a little look through domain events, and then we'll look at how various interesting bits of business logic can then be written in terms of reactive programming as well. Okay. So, sentiment analysis. Now, this is a research topic, and I didn't really fancy doing that much research, so I implemented a really, really stupid sentiment analyzer, okay? Basically, it just has lists of positive and negative words. And if it sees a positive word in the tweet, then it gives it a +1, okay, for each of the positive words. And if it sees negatives, then it gives those, okay, -1, and it just tots up all of the scores. And if you get a positive score, it's a positive message, and if you get a negative score, it's a negative message. Okay, it's really, really simplistic, and you'll be able to see it sort of fall down in various interesting ways. But, okay, here is the code. Now, I've written this in terms of observables. What I'd like you to notice is that actually all of this code down here looks exactly the same as if you would have written it on enumerables as well. Okay? If I actually had IEnumerable here and here, I actually could have written exactly the same code. There's something very deep in that. That sort of tells us the duality is actually holding up. Now, what I do here is I have an observable of tweets to score, just strings, okay, the text. And here I've got two lists, okay, of positives, negatives. Okay, there's quite a few more of them in my code. And what I'm doing is I'm taking the tweets to score, and I'm observing them, and for each one I observe, I here turn it into lowercase and push the lowercase value on into this, which does the scoring, okay, and it just returns a new scored tweet object containing the tweet and its score. So what we're doing here is just setting up something where we get an observable in, we observe it, and we ourselves give back an observable, okay, and all the things that we observe being returned will have had a score added. It is just really kind of curious how, this is going to deal with all the inherent asynchronies behind this, but it looks very, very much like the normal code we would have written in a normal synchronous style. Okay, so what I'm going to do before I go linking this up to Twitter is just take some sample tweets. I've chosen cats. Okay, so here are some positive and negative imaginary tweets about cats. Now, what we'll do is we'll turn these into just a sample feed, okay, that pretends to post one of these a second. So here we go. This is just a little method I wrote, sample feed from, okay, and it returns an IObservable, a string. And what I'm doing here is I actually want to take this enumerable thing and just zip it with a pulse every second. Okay, so interval we already saw. That's something that you can observe, and it notifies you every second. So every second it's notifying this zip, okay, and the zip is actually zipping that with the list of tweets. This is kind of curious because what we're doing here is we're actually, we have a reactive thing on one side and an interactive thing, a list, okay, on the other side. And they actually can just be brought together like this in a zip. This is another place where we get really grateful that they're dual. Now, what will happen here is we'll receive the time pulse. That's just a number, 0, 1, 2, okay, the number of seconds. We'll ignore it. We'll take the tweet. That's what we care about. And we'll just send that one on, okay? So we're just selecting the second of the two. Now, let's put it all together. So just for my little sample here, I've got some tweets about cats, some tweets about snow, and I'm going to merge the two together, okay? That just takes them and makes a single observable stream, and whenever a cat one arrives, it gets passed on, a snow one, it gets passed on. So what we'll expect is, a cat and a snow one to come sort of together and be passed on. And you can actually imagine merges having to deal with the inherent sort of asynchrony of that. I have two timers going off at the same time, just about, okay, and they're coming in there. So what I now have is scored tweets. Remember score I wrote earlier, okay, and here I get out an observable. And finally, we'll just do a where, and then this is just a little console application here. So all I'm going to do is whenever I get an interesting tweet, that is one whose sentiment score is not 0, we'll say positive or negative and display the tweet. And if we do this, then we should see Let me find it. Here it is. Okay. So in a second, we're getting some stuff there. Okay, and you can see it's scoring them positive, negative. Okay. So that was just my imaginary data. Okay. So let's link it up to Twitter so we can actually have some fun. Now, how easy is that? Well, the answer is we're on .NET, there's NuGet, there's lots of libraries, so I don't actually have to do too much hard work at all. And I found 2 libraries that would help me in my, my mission to do stupid sentiment analysis on Twitter. I found Link to Twitter, which is a nice library that basically lets you express Twitter queries using Link. It doesn't know about reactive, sadly, and we're going to have to do something about that. But the other one is Newsonsoft's nice JSON parser, because Twitter sends us these things in JSON. Okay, so the slight problem that I've got is that there's no way for me to take this library and have it give me an observable. Okay, it just doesn't do that. But it does know how to go off and call this streaming API. Okay, and every so often it pushes tweets to me. So all I actually need to do is do some mapping from it over to the way that observables work. Now, the good news is that Rx knows that the rest of the world doesn't think its way yet, and it actually provides lots and lots of mechanisms so that you can get from other paradigms, either events in UIs or the thing I'm about to show you, and actually get them into observables so then you can apply Rx. And that's what I'm going to do here. So here is just a really small example, not at all involving Rx, okay? Just if I want to go and get Twitter to tell me every tweet where somebody mentions the word snow, okay, which they're doing quite a lot at the moment due to the weather conditions in certain parts of the world. Now, what we're doing, and this code isn't quite so important here, but we're just actually setting up the query over on Twitter, okay? And when we say start async, what this will do is it will give me a callback each time a tweet arrives. And then all I'm doing here is I'm actually just outputting it to the console. That actually dumps the JSON, okay? So what this is going to do is it's just going to output it on the console every JSON blob that I get sent. Okay, so it's pretty easy to get those. But of course, this doesn't give me an observable. So how do we get that? Well, there's an Observable.Create. Let me just show you a simple example of that on its own before we put all the pieces together. What Observable.Create does is it gives you an object. Okay, you give it a lambda expression, it calls it right away. Well, it doesn't call it right away, it calls it at the point that you actually start observing. Sorry. Okay, and at the point you start observing, you get this object, and then you get to call onNext to supply more values, and that pushes them down the pipeline. And it's important to understand that there's not really any sort of inherent asynchrony there. So when you actually push that thing through the pipeline, you're actually waiting for it to be pushed through. Okay, it's asynchronous from the point of view of the person who sets it up, but from the point of whoever calls onNext, it's not. So what happens is we call that, okay, that and that, and what we've done is we've got an observable now which has these 3 values pushed through it, and then we say it's completed, and then one of the really important mechanisms is not just subscription, but unsubscription, okay? Saying, I'm no longer interested in receiving any sort of notifications from this observable. And the way that is done is with the disposable interface. Now, I don't actually have any cleanup work to do on unsubscribe here, so all I'm going to do is just return an empty disposable. We'll have to do something a little more clever for the real thing, because what we want to do for the real thing here is actually say to the Twitter stream, don't tell me any more about this topic because I'm done. The final piece of the puzzle before we make our observable is that we need to pass the JSON. Okay, here's a really simple little DTO. It's got a user field and a text field, and all I'm doing is just using JObject, okay, for Newsonsoft, and it's one of the nice bits of dynamic usage that you can do in C#. Okay, I mean JSON is essentially very dynamic in nature, anyway. So it's kind of nice. We can pretend we're in JavaScript for a few moments while we deal with it. Okay, so now that I've got that, let's put it into one piece of code. It looks like a big slide of code at first, but you've actually seen most of it already. The first line is just a call to Observable.Create, but we're handing back tweets this time, that object. These lines of code are what I showed you before, okay, and that are going off and describing the query that we want to do on Twitter. We've got the topic here, that's actually passed as a parameter to the method this is in. Now, ignore the var for a moment, okay? This query start async is exactly what we saw before when we were doing the little example where we just got the data from Twitter and just stuck it out on the console. So here's where we do the interesting stuff. Okay, see the on next, we take the content, we pass it, and we shove it down the observable pipeline. Okay, and that notifies anybody who is observing. And the only other thing that we have to take care of, and the reason this code has a bunch more lines, is disposal. And I've just got a Boolean here, okay, and whenever we decide to dispose this, it sets it to true, and the next time we actually get past something, we call close stream. Okay, and that means that we will not be given any more tweets on this topic. So that's just a little bit fiddly to set up the disposal. What happens if I don't dispose it? Basically, we will stay receiving over the network all of these things from Twitter, but we will do nothing with them. Yeah, we'll just drop them on the floor. It'll be a huge waste of bandwidth, and that's about all. But of course, you know, we say that, but of course, Twitter is, you know, there's a rate limit of how much you can do this. So, you know, it would map to a real cost. So if you do this, I mean, all the things that are inside Rx know how to deal with the unsubscription side as well. It's very tempting when you start out to just hand back disposable.empty and say, oh, I don't care. If you do real world stuff with this and you do use create and you are getting values from something that ties up resources, make sure you do this bit as well, because otherwise you'll potentially end up with a lot of waste. Okay, so I tried to set a good example. Okay, so now I have this nice observable of tweet. Okay, I've got a way that I can be notified whenever something about a topic shows up on Twitter. Let's wire it up. So let's take tweets about Justin Bieber. Okay, why not? And we'll make an instance of our sentiment analyzer. I've shoved that code off into an object now. And what we'll do is we'll just select out a new anonymous object containing the tweet and the score. Okay, and remember that these are all observables. Okay, obs is, of course, but scored is as well. Okay. And what we'll then do is we'll actually just use exactly the same pattern as before. I've made it a little bit prettier this time. What I've done this time is if the significant ones, okay, that's just an observable of scores that are greater than 0. And then down here, okay, what we have is just saying, is it greater than 0, do green, if not, do red, write them out. And if I do this, it's actually going to work on real data. So I guess we should try this out. Okay, here it is. And I think it actually is Justin Bieber as well. And actually I can make the font just a little bit bigger for you. And oh, there they come. There they come. This is okay. So okay. I hope nothing too bad comes out. Like there's 3 levels of stupid, right? There's doing live demos, which is sort of stupid. There's doing live demos involving the network, which is very stupid. And there's doing live demos with data you don't control coming over the network, which is the ultimate in stupidity. Okay, so that was Bieber. Okay, so a lot more red than green. People look entertained. You probably saw something I didn't. Okay, so of course, a console app's boring. So why don't we go and build ourselves a little UI? okay, a little WPF version. So let's take a look at doing this. Now this is where things get really exciting. And the reason that things get really interesting here is because when we're dealing with Twitter on its own, okay, it was kind of cool, we had all of these things coming at us, and it was reactive and very nice. But when we have the user interface, we have a couple of extra worries, because we have all of this, UI going on as well, and of course it's not a very pretty or clever UI. You won't hire me for UI design after this, I can guarantee that much. But let me show you the trickiness. So what I want to do in this topic box at the top here is I want to put in something that we'll look for tweets on. Let's do Bieber again, because it was apparently entertaining. Okay, and what I want it to do is to go off and start just throwing me some tweets in here. Okay, oh, they're all extremely negative so far. Oh, okay, some positivity. So what you can see going on here, though, is what other topic shall we do? Let's do the snow, okay? And what I want it to do is I would like it to dynamically adapt. And oh, look, we've got a Unicode snowman. That's great. Yeah, there's some. Anyway, people complaining about the snow. Okay, we could do one more. What else do we want? Someone suggest something. Java. I don't know how many people will be talking about Java. This is live data, okay, so no, nobody. That's, oh, no, Java. Well, not so much about Java. Oh, is that even relevant? No. Oh well. Not enough people are tweeting about Java. Who's got a popular topic? Beer. What's trending? Beer?
You see at the bottom of the positive ones? That's mine.
Oh! That is the best audience participation ever in a talk. Thank you. Somebody had to. I didn't see that one coming. I totally should have. Beer. Surely people are, oh yes. People are talking about beer. Yeah, lots of bad things about beer. Best damn beer. Yeah, okay, he got that one right. Okay, so, okay. So the question is, how do you actually deal with that text box? That's actually a little hard, because what's kind of going on there is, the user is changing what they want to do, and it's almost like we want to drop one stream and then just pick up the other one. And that's kind of tricky. Now, if we actually just and I'm actually going to do a tiny bit of live coding. I'm not going to live code the whole thing, but what I would like to do is just show you the sort of beginnings of this, and now I'll show you the full thing. But what you can do is you can actually take observable and say from event pattern, and what I can do is I can say text changed event args. Okay. Now I've got a text box, which I believe is called topic. Okay. And I want the text changed event. Now what I've just done is I've actually just taken an event, a normal.NET event, and turned it into an observable. That means that now I've got all of the nice combinators. So what I can do is I can actually just do a dot. Actually, let's just subscribe. Okay. And what I'll actually get in here is actually I'll get some event data. And what I can do is I can take the sender, that is the text box. Let's just cast it into a text box. Okay. And then we can pull out the text. Now, will this work? No. And the reason is that I wanted to, actually let's message box show it. Okay. Let's see if this, yeah, now it's happy. Okay, good. So if I run this, it hasn't got anything else wired up, and I type a character in here, okay, then immediately Okay. Okay, now the problem that you can see with that immediately is that if every time the user types in a character we go and start trying to connect, it's kind of going to be annoying, okay? Because what will happen is they'll type a B and we'll go and connect to Twitter, and they'll type an I and we'll be like, oh, screw that, let's connect again, okay? And what we want to do is we'd actually like to have a little bit of stability in this. So one of the really nice things about Rx is it makes dealing with time quite easy. And what I can say in here is I can actually just say throttle time span from seconds 1. Okay. And let's actually just do a select here as well and just project out the message just to factor that out. Okay. And then we actually get the message in there, and we show that. Okay, that's just a little small refactor. But the important thing here is this throttle. Now what throttle will do is it will make sure that we never pass along a value until the thing has been stable for a second. So, okay, so if I start typing Bieber and I stop, and what have I done? Oh, and that's interesting too. Oh, yes. Okay, here's what we should have done. So, does anyone want to hazard a guess as to why I swapped the two around and why this will probably work now? There you are. Okay. Hey, nice. So why did it not work the first time before I moved the select above? Turns out that throttle is one of those things that introduces time. And when you introduce time, you introduce threading, okay? Which means that you're not accessing this thing on the UI thread anymore, which means that WPF is a sad panda, okay? So, yeah, we can't do that. Okay, but what's nice about this is that if I just take off this this subscribe, and I go and I stash this away in a variable, what I now have is an observable that tells me whenever the topic that I want to look for tweets on has changed. So what do we want to do from that? What we'd like to do is we'd like to take our, of course we have our Twitter observable here. Okay, this is the bit of code I wrote before, and I can pass it a topic. Okay, so that line of code there is the way, okay, we can't do it right off. This is the way that we would actually go and make an observable that knows about this topic. Now what we'd like to do is to make one of these each time the topic changes and then unsubscribe from the last ones. Now there is something that does exactly that, and it's called switch. How do we use it? We say observable.switch. Okay, and this type signature here is kind of one of those things that blows your mind the first time you see it. It's an iObserver of iObserver of tsource. Okay. It wants an observable of observables. Huh? Okay. Let's step back and think about it calmly. Okay. What we're actually doing here is we have an observable of, well, strings, actually, just the topic. And if what I do is I take the topics and I do a select and I map each topic to an observable about the topic, okay, we've got an observable of observables, okay. What I've done is every time a new topic comes through the pipeline, I make a new Twitter observable that will push me things from that stream, and because I've passed it off to switch, that means that it's just going to go and switch me over to that one. So what I now have is a stream of things coming from Twitter. Okay, and if I actually was to take that and okay, and then let me just rearrange the code so it doesn't confuse us all. Okay, and then if I actually take this one, let's throttle this to 2 seconds. Okay, and then I just subscribe to it. Oh, sorry, it doesn't just take a number. It needs a time span from seconds. Thank you. To okay, and we'll put the tweet into a message box. Okay. So what this should get me, in theory, what have I done wrong? Oh, that's not a string. There it is. Okay. Yay. Okay. If we have this one, what we should find is that if we type in, let's do snow, that was quite active. With a bit of luck, I will get a message box soon. I hoped. No, I get invalid JSON. Joy. Oh, oh, look at that. Okay. Of all the things, Okay, and if I change that, then hopefully it'll be slightly less disastrous and that we'll not get a bunch of invalid JSON, but at some point we should hopefully get a box about Bieber. Now, this is exactly, maybe not, but this is almost exactly the code I have over in the real thing. Okay, let's just go and take a little look at it. So, excuse my lack of view model. This is just demo code, okay? But right up there, okay, here, these lines of code, okay? This is the thing that we just saw. So it takes the topics. There is a place I just factored out. There's topics. Okay, so it's doing exactly the thing I showed you. It's just mapping out the text box and throttling it. And then up here, we make a new sentiment analyzer. We do the thing that I just wrote. Okay. And then the rest is not too bad. What we're going to do is we're going to score the tweets. That's just the same as in the command line version. We will then do publish, okay, because we're going to have positive and negative things looking at this. And if we don't do the publish, what will happen is that when I split this off down here and I go and do a query on scores for positive and then another one further down for negative, if I didn't have this bit, we would actually go off and connect to Twitter twice, process all the streams twice. Okay, we really do not want to do that. Once is enough. So we have published there, okay, and all I'm doing in that little method here. Okay, now there's at least one thing worth talking about in there. Well, there's two things. Okay, the first thing you'll notice is that when I did the command line one, it was completely spewing out tweets all the time. Okay. When I had this one, it was just doing a nice one each second. That's what sample does, okay? It just makes sure that I get the latest value, but only to the granularity of a second. And if there's more than one in a second, then it just overwrites, okay? And it just makes sure that I never see more than one per second, which is why we could read it more easily. Okay, and then we just get the text. And then this final bit is quite important. Now, what I'm doing in the subscribe is I'm calling store latest. What does store latest do? This is the thing that actually goes and adds it into this collection, which is data bound from my UI. Now, if you're going to update things on the UI, you have to do it on the UI thread. How do I make sure it happens? I call observe on dispatcher. That forces anything that follows to be executing on the UI thread, okay, and then it's happy. So that's our little WPF simple Twitter sentiment analyzer. Okay, what I propose is, I've talked for a while, I've got a few more things to say. Should we just take a few minutes breather? Just to maybe go to the bathroom or whatever, and we'll resume in like 5 minutes, and I will go through the final example, but not before talking a little about the main events, okay, and then we'll do an example in terms of that. Okay, let's get this finished up then. We've got another 30, 45 minutes to go. Okay, so one of the things that I discovered about writing just normal business applications over the last years is that you can actually recast pretty much most domains in terms of a stream of events. And just to sort of talk about this a little bit and sort of show you how you get there, let's just look at a very boring little business object here. So imagine we're visiting a cafe and they have some system for keeping track of what we buy. What drinks, what food. So I make a tab, okay, it's for table 2. My waiter is called Pedro. And I order some coffee, which costs me $2.50 in some currency. And then my drink gets served, okay, and I pay free of that currency, I guess, leaving a nice little tip. Okay, so what's kind of going on in objects like this is that the constructor kind of specifies some initial state for the object. And then each method call just takes the object to some new state. Now, one of the things if we write code like this is that the method calls really capture the language of the concept we're talking about, which is kind of nice and where the whole modeling aspect of OO comes from. The thing is that, of course, most business apps don't look like this, or at least most of the ones I keep seeing don't look like this. What they actually look like is a bunch of database accesses, because people say, well, we can't just write a bunch of classes representing objects and keep them in memory because we have to persist. And we need to persist stuff, and we need to integrate stuff, and we should just use a database for that, and then we all end up with code like this, okay, which basically just goes updating and inserting into tables and so forth. And a lot of the nice language tends to be lost, and it was very much sort of summed up at the time I was with a customer, and they decided that what they wanted was, me to teach them a bunch of stuff, and then said, can we have a couple of hours where we just ask you stuff? And I'm like, oh no. And so we did this, and one of the really interesting ones that came up was, they said, well, in all the OO textbooks it would be dog.bark, but in all the sort of code that we have here and that a lot of our previous employers, the code looks like dogcontroller.bark, and you pass in the dog. What's going on? And I said, oh, procedural programming. That's what's going on. But it's very common. And one of the sort of things I realized is that, it's not worth sort of fighting the procedural trend everywhere. Some things really are just, very, very boring and unimportant in a code base. A list of things. We don't care about these things. But where there's workflow, and where there's lots of interesting things happening, particularly maybe with a bit of concurrency, that's at the real heart of the domain, I found there's quite a lot of value, even putting Rx aside, into trying to model domains into events. Now, in the sort of what we call the core domain, this is a place where I'd say, it matters that we try and get the language of the problem space into the code. It matters that we have well-tested code. It matters that we try and express the tests using that domain language, so we might be able to use them as a communication tool. And, we may need to scale if this is at the heart of things. It's maybe the growth area. And we may need to sort of handle a lot of inherently concurrent things going on. So if you have a cafe, then you've got a few waiters. Of course, you're going to have them taking orders at the same time and handing them in at the same time. That's just part of the business. So, one thing that people sometimes say is, let's just take, an object with nice method names, and, each method call takes it to a new state. We don't have any state outside of the object, and then we just serialize it. Is this a good idea? No. Okay. Because part of the problem with this in a lot of the times when I look at object orientation that I've done, and I look at it and I say, this feels kind of good, what I realize is that I can view the fields of my object as a model of the thing that I'm talking about. And we encapsulate that. What we're actually doing is encapsulating the way that we represent some aspects of the world that we're modeling with this object. And that representation is very related to the things we need to do with it. Okay, you probably know that if you have a list of things, and you're going to want to ask the question, is this thing in the list? Very often, you don't choose a list as your data structure, because you'll have to do an ON operation going through the list. You know that you choose something like a hash set, so you can very quickly ask the question. And this is exactly what kind of goes on as requirements evolve. You know, we might not have had a requirement to answer the is the thing in the list question, then a new requirement comes in, and of course, you know, the person interested in the business logic doesn't care about what you implemented in terms of, but you as a programmer look at it and say, oh, of course that should be a hash set there. And because it's encapsulated, you can just change the representation. And that freedom is very important. So sometimes, you know, I found that even when working in very OO code, you can actually get a lot of inspiration from the functional world. After all, every single problem's already been solved in Lisp, apart from nice syntax. So one thing that I realized is we could actually define this notion of pure objects. An object that doesn't do any I/O or access anything static or do any kind of random number generation or date time, okay? The only thing that this object ever receives in terms of data is stuff that is passed in as parameters. And if we have such an object, what can we say about it? Well, we can say that if you were to take an object and do exactly the same set of method calls on it again, then you get to exactly the same object. This is where it starts to get a little bit interesting, because then you say, oh, well, we haven't broken encapsulation. You know, we haven't, you know, gone and messed with the fields, but we've got something now where if we just do it again and again, we get to, you know, the same state. Can we use these to persist? You know, so, well, almost. I mean, you look at it and you say, well, we can't persist a method call, but I can make an object representing a method call. That's the command pattern. Okay, so the method name becomes the class name and the parameters become fields. Right? And then we get a uniform interface for applying them. So we just have a do method where we give it the command object. That makes it very easy to just play these back. But there's a problem with this. You know, I say, I get it, let's persist those. And again, the answer is no. And the answer is no because you've tied your hands again. Okay, just like we tied our hands by not being able to modify the state model last time, this time we've made it so we can never change the business rules. That also kind of sounds bad. Most systems, or most things that go on in a system, can basically be represented as 3 steps. This is my every system ever diagram. Okay, so basically we get a request in, we do some validation on it. If we accept the information within it, we get a new fact, which we decide is now true, and then we disseminate it. Okay, and well, that's basically most systems. So the thing about this is that the command represents the request, okay, and not the new fact. And this is the thing that represents decisions. Okay, this is the trustable thing. Once we've decided something, it's a decision. Okay, so, you know, if I was like, you know, stand on your head, you can refuse to do it. Okay, one day I'll do that and someone will, but you can refuse to do it. But a fact, you know, that's already an established thing. So one of the things that, you know, you learn from functional things, especially like Rx, if you look at all the Rx queries we've built, all of them are involved in something coming in, you do something, and then something comes out the end. And it's only right at the end of the pipeline that we actually have anything that's not pure, okay? Anything that's not, some data comes in, and it works on it, and so on. So one thing that you kind of realize from that is that it's actually kind of important to distinguish a second thing in all of this, and that's events. Events are basically ways of talking about things that happened. Okay? If earlier on, when I sort of had my my nice little, what do we think of Beaver today application, okay, and the user was typing in the text box, I got a text changed event. I can't say, oh no, they didn't. It's an event. It's saying what happened. And we can actually introduce into applications this whole notion of domain events. Events that basically record a decision. So a tab was opened. Drinks were ordered. Okay. So basically, every interaction with a system can come to be expressed as a command, goes into an object, which has a nice bunch of encapsulated state in there, and either it agrees that this request is sensible, and we get an event or events, or it says, no way, I'm not doing that, and you get an exception. And we tend to call them the happy path and the sad path, at least the folks I work with, which is kind of nice. Now, we'll get back to RX in just a moment, but there's just a couple of other things that are worth realizing about this. The first is that events can also provide a persistence mechanism. Because now, if you actually persist the events, you can always get the object back to whatever state you want. What's nice about it is that because it's the events you've persisted, the decisions, you can change the representation of the object whenever you like. It's very refactorable. The other thing is that this actually is really great for testing. And I've had a lot of fun over the last few years discovering this and writing a bunch of tests in this style. Because basically what you realize is that if you take TDD's arrange act assert, or you take given then when then in behavior-driven design, it maps perfectly to some events that describe the history, a command, and either some more events recording the decision or an exception. So you can write tests like that. Okay, given there's no history, when I open a tab, then the tab is opened. Or, given no tab, when I place an order, I get a tab not opened exception. Okay? So, you'll note we're actually using typed exceptions to convey the failure reasons as well. This is something else I found very interesting and very valuable. I think in some ways typed exceptions are underused. I mean, exceptions are good for indicating failure, but there's a bunch of times you can avoid logic leaks. For example, if you have a calendar object, and you try and do a booking, and it says, no, you can't actually, book at this time. What about if the exception you threw actually had suggestions of when you could book? Then the logic for computing those is kept inside of the calendar object rather than shoved somewhere else in the system, leaking out. So there's a lot of benefits for doing this. One of the interesting things about doing these kinds of tests, by the way, is that they're behavioral tests. You never poke into object state. What that means is that the only way that you can check that something took effect is actually by writing another test that depends on it doing so. For example, given we opened the tab and we ordered test drink 1, if I try and mark test drink 2 served, I expect to get a drinks not outstanding exception because I never ordered a drink number 2, just a drink number 1. So, what's interesting is the failure would have happened applying this event. The outcome is down there. But you'll note that we never go and poke at object state. Now, of course, the RX side of all of this is that as soon as you do this, your objects are now spitting out these nice streams of events, which are perfect for going and dealing with in RX. And, just like we saw that you could deal with time very nicely with RX, you can deal with user interface things with it, you can also deal with, events from your domain. So let's do one final example. And for my example, I chose a domain that I actually encounter more than I kind of wish, which is airports. And the announcement systems at airports that tell you you're going to be late home and stuff like that, okay? And one of the things that I kind of realized about this is that that is very sort of asynchronous and eventy. I actually found one of them that wasn't built very well. It was making one announcement, and then suddenly it cut it off to make another one. And I'm like, no, you should have used Rx. But anyway, okay, here are some events that might happen in our airport domain. Okay, a departure gets delayed, a departure returns to being on time, it gets cancelled, a gate gets assigned, a gate gets changed, a gate gets open. Okay, and you can see all of these are events, things that happen. And if we're going to build an announcement system for the airport that just tells us what's going on, then it's kind of going to be nice to build it out of these. There's one class that I haven't talked about, or there's quite a few classes I haven't talked about. There's one that's very common that I haven't talked about in RX called subject. There's various kinds of subject. The reason I didn't talk about them so far is because you typically don't want to be using them. But occasionally they're the right thing. A subject basically is something that you can use to publish events. And it's an object, so basically you call onNext on it, and it will pass it along to anybody who is observing it. Okay. Now, this is very nice in the sense that for all of our events, we can actually just create a subject, okay, that you can observe. So what we'll be able to do is write code saying, oh, I want to observe departure cancelled events. Okay. So whenever a departure is cancelled, I just observe those. So I built a little test application. Okay, I played with WPF again, and I got this thing out. And you select a flight. Actually, let me show you this before we dig into the code. This is kind of fun. And there it is. Okay, so let's try this. So let's change the departure time to 13:40. Okay, there we go. So you get the idea of what it does. Okay, we'll have a play with it in a moment. Now, what I'm going to do is just to build my UI. I'm actually going to just fake up some events. Okay, so in real life we would have a bunch of systems across our airport which would be producing these events, and we'd be getting them and receiving them, and there'd probably be a network in the middle somewhere. But for my little sample app, okay, what I do is I just make a new gate assigned event. Add flight info just actually takes that and throws in the flight that we've selected, okay, and then we just onNext it. That is, we pass it to any observables. So we push it down the pipeline. So that's all that I'm going to be doing when I click on the UI to issue event. Okay, it's calling onNext on the subject. And in reality, what you would do is you would wire this up to something that is sort of your message bus or event aggregator or whatever you have in your application. Now, let's start on the announcer. So what the announcer is going to do is it's going to expose a property here, which is an iObservable of string. These are the announcements. Okay, they're the things that were being spoken and were showing up in that text box. And let's start out with gate changed. That's quite an easy one. Okay, all we'll do is we'll take gate changed and we'll just format a string containing the stuff in the event. Okay, and yeah, that's nothing particularly new. Now, what I've done over in the UI is I've actually got an observable collection, which has nothing to do with Rx. This actually predates it by quite a long way. But this is something that my user interface can data bind to. And what I'll do in here is I'll just make it to the beginning. So we have the announcements here coming in, okay. And I'll observe it, and you'll note I've used observe on dispatcher again. And the reason I'm using observe on dispatcher is because I'm passing announcement.add, the add method, on this, okay? And what's going on there is that it's a UI update, because this is an observable collection, meaning that whenever I change something in this collection, it appears on my screen, okay, in that text box. Because it's a UI update, I need to make sure it happens on the UI thread. So again, just need to take a little care over that. Okay. So what we'll do now is we'll take a look at the speech. Okay, this is a second subscriber. This is grabbing a speech synthesizer. This is a Microsoft Mary. Okay, and then we just say the message. Okay, and the thing you might notice is that at no place did I actually do a .publish somewhere to make sure we didn't get duplicate work going on. The reason is that I'm using a subject, okay? And a subject already is something that I give things to, and it passes it or notifies all of the things that are observing it. So we don't actually have that problem with subjects. Okay, so wiring up the say thing. Okay, we subscribe. I've actually shoved this in the do. You might be curious why I've got it in do rather than having it in a subscribe. Any ideas why? Carl? It is a side effect, though I could do side effects in subscribe as well. It turns out that subscribe is allowed to fire multiple things off at once. Do will only actually do one, okay, and they will back up behind it until the side effect is done, and then it will go on. It assumes if you're doing side effects, you're doing sufficiently nasty things that you don't want two of them executing concurrently, so it makes sure it doesn't happen for you. Okay, that's nice. So what this fixes the problem at the airport, where they spoke one message and cut it off to say the other. Okay, they should have done a do instead of subscribe. No, because most airports don't run open announcement system or anything like that. That'd be cool, open airport. The TSA would love it. Yeah. Okay, so of course, announcements don't just consist of gate changes, there's lots of them. So what I'm going to do is I'm going to take my code for gate changes and I'm going to factor it out into a method, okay? And then what we'll do is we'll go and add a few more. So let's add cancellations, and what we'll do is we'll just take the gate changes and we'll merge the cancellation stream in. So I've got these two event streams coming together, okay? Which means that even if we have a cancellation and a gate change at the same time, it'll still do one and then say the other, right? So what we are doing in here, again, just formatting out the string, okay? So that's not too hard. Now, if you've been around airports, you'll know that every 30 seconds, or so it feels, they like to tell you not to leave your luggage unattended. If you use airports regularly, you really know not to leave your luggage unattended. Now, how do we do this one? Well, what we do is we take interval, 30 seconds, okay, and again, because we're going to merge them all into the same stream, it won't interfere, so it's all very neat. Now, delays are a little more involved, because what we'd like to do is to compute how big the delay is and only tell people about 10-minute or longer ones. Okay, if the delay is like only 2 minutes, like nobody really cares. If it's 10, yeah, we should probably start telling people so they can spend longer buying, schnapps or something in duty free. So what we do is we take the delay, okay, this object, and it's got a new time and an old time. And I can just actually calculate, and I can use let. You'll notice I've expressed this one in link comprehension syntax, okay? Just because it worked out neater. Let without the link comprehension syntax is kind of harder to do. You have to do anonymous objects, and it's kind of boring. So we'll do this instead. And then the duration is greater than or equal to 10, and then we just format out the string. Okay, and remember, all of the time, the data is getting pushed through this process. So if we eliminate it with the where, we never bother doing the string format. Now, there's a slightly tricky problem, because there's one more kind of announcement we want, which is gate opened. Does anyone notice what's missing in gate opened that would be really useful for telling people about it?
The gate.
The gate, yeah, okay. Now, why is the gate missing? Well, the answer simply is that if we go and just take a look at our events, okay, then gate assigned has the gate, and gate changed has the new gate. But when we open the gate, we've already emitted the gate information before. We're just saying, oh, it's open now. Now, it's slightly contrived, and it would be easy to fix, maybe, but the point is that this happens in the real world. Okay, you get events which don't contain the full picture. And what you need to do is to actually take several event streams, keep an eye on all of them, and actually make sure that you have the information aggregated that you'll need to do what you need to do. Now, Rx is also pretty good at that as well. And how do we do it? Well, basically, what we want to do, if we think about it data structure-wise, is we'd like to maintain a dictionary, a lookup table. Okay, so every time we find that a gate has been assigned or a gate has been changed, what I'd like to do is just to shove it into a dictionary. Now, this sort of jars a little bit with Rx because as soon as we start dealing with dictionaries which are mutable and we're dealing with streams of things happening asynchronously, it's sort of asking for trouble. But what we do have is immutable dictionaries in .NET now. Not built into the .NET framework yet. You have to get them as an extra library still. But basically what a immutable dictionary does is every time you put something into it or take something out of it, it doesn't mutate the existing one. It just gives you back a new dictionary that's got the thing added or has got the thing removed. Okay, so you always get a new one out. So what I'm going to do is I'm going to take the stream of gate assigned, and then just going to project it out to a tuple. Okay. And then I will take the gate changed, and those will be projected out to a tuple. And now you'll notice that these two have exactly the same type. Okay. So I've taken these two events and turned them into a flight code and a gate number. Okay. That means I can merge them because they're the same type. What I can then do is use scan. And what scan does is it basically is a little bit like aggregate or reduce, that you might know it by, but basically it produces every single value. Okay, so every time we get some kind of new event in here, what we'll do is we'll take the current dictionary. Okay, we start out with an empty one. We get the current dictionary in ag. In update, we get the tuple, one of these two. And all we do is we do set item, and we just update the entry in the dictionary, and it makes a new one. Okay. So that's latest gates. Okay, that is an observable that basically sends a new dictionary of gate information every time a gate is assigned or changed. So what I can do with it is I can then use a combinator called combine latest, and what that does is it gets the latest values, okay, of two things. So what's happening is I've got this stream of events coming in, which is the latest gate information, which changes every time that I get a new gate assignment or a gate change in. I've got the gate opened events, okay, and every time they come in, that means I need to make an announcement. I'm making a tuple of the two, okay, and then I'm doing distinct until changed on the first one. The first one being the gate opened. So what it will be doing here is it will be saying, always pass on a tuple of the latest of these two, but don't actually go any further unless it was the one on the left that changed. Okay? So basically keep track of the latest gate information, but only actually produce a message if it's the gate open thing which just had an event arrive. And then we just produce the message with the information from the two objects. And we're done. Okay? And then we just piece all of these together. We just do a big merge like that. And notice how nice it is to compose. There's actually an observable.compose, which I could have passed them all off into as well, which actually would have looked a bit, sorry, observable.merge. That takes a variable number of arguments. That would have been nicer. Okay, so we are done, and let's just have another little look at it, just so I can show you that it doesn't say two things at once. So if I assign a gate, let's assign gate A2 for this flight, okay, and let's change its departure time, and then I'm going to assign it a different gate too.
123 to Oslo is delayed until 13:40.
Okay, so we got the delay in. And when I do open gate, okay, hopefully I will get the C3, because that was the latest one. Yeah. Oh. Okay. So, there we have it. Okay. So, RX hasn't just appeared on .NET. It appeared there originally, but these days it exists on a whole bunch of other platforms too. I've been working on getting this stuff into Perl as well, into Perl 6, and I've got it mostly working, which is cool. Goodbye. Okay. RxJS is one of the very exciting ones because basically the web is full of this stuff. Okay, it's full of users doing stuff with text boxes, and you going and calling web services, or REST services, or any of that thing. And now we've got WebSockets as well. Where we have a way of actually having two ways between the client and server. And what's very interesting about it all is that if you realize you can now do reactive queries over on the server, have the results being pushed out to a WebSocket, and then go and do further processing of it in JavaScript, I think there's going to be some really cool stuff to be done there, where you're managing to basically get reactive all the way through from server to browser. And that's an area I haven't done anything like as much as I'd like to with yet. But it's something I hope to have lots of chances to explore, because it seems like a very powerful set of things can be done there. Okay, so hopefully it was some fun. Hopefully it was kind of interesting. I think that reactive really, as a paradigm, is very helpful in dealing with asynchrony. I think asynchrony is always going to be different. Even with the niceness of Rx, you still saw me throwing in things like observe on dispatcher. Okay, basically ways to deal with the fact that there's threads involved, there's mess. Okay, not everything we deal with has this nice pure view of the world. But I think that really this is a very helpful step in the way we deal with asynchrony in a bunch of real-world scenarios. And I really like that the way it works means we can take a lot of knowledge from dealing with enumerable things, particularly if you're used to dealing with LINQ or anything like that in other languages where you have those map, filter, and whatever, and being able to reapply that knowledge on asynchronous things. The duality really shines through. In many ways, this is one of my favorite examples of a theoretical result leading to something really beautiful in everyday programming. I'd love to see more of that as well, and it's very encouraging for that reason. Okay, well, thank you very much for coming, and this is how you hunt me down. If you're interested in the code, drop me a mail, but what I'll probably do is throw it on a GitHub repository somewhere under the Edgement AB GitHub account, so you can get at it. As I said, I teach stuff, actually a bunch of this stuff, and a lot more fun can be had in this course, where, well, you can imagine. It's where I stole the sentiment analysis from, and but we do it for some hours there instead. Anyway, that's some of those. So thank you very much, and I guess I maybe have a few minutes for questions. I don't know, do I? Oh, it's not 8 yet. I can do questions. Does anybody have a question? And I don't see anyone. Okay. Well, in that case, I will say thank you very much for coming, and it's been a pleasure. Thank you.